Right now, at the exact center of our own galaxy, there's a black hole. Not somewhere billions of light years away, inside the same galaxy you're living in right this second. It's called Sagittarius A star, and everything in the Milky Way, every star, every planet, including our Sun and Earth, is slowly orbiting around it. We can't see it directly. It doesn't glow. It doesn't explode. It just sits there, quietly anchoring an entire galaxy of over 100 billion stars with its gravity. And in 2022, for the first time in human history, we actually managed to take a picture of it. To actually reach it, we have to travel about 26,000 light years from Earth. That's the distance from where we are, out in one of the galaxy's spiral arms, all the way to the very center. For comparison, light from the Sun takes about 8 minutes to reach us. Light from Sagittarius A has been traveling for 26,000 years just to get here, meaning we're seeing the center of our galaxy as it looked long before recorded human history even began. Even traveling at the speed of light, this journey would take longer than our entire species has existed. We're heading toward the gravitational anchor of everything we call home.
Astronomers didn't actually see this black hole to discover it. In the 1990s, teams of researchers pointed powerful telescopes at the center of our galaxy and began tracking a handful of stars orbiting an apparently empty patch of space. What they found was strange. These stars were moving incredibly fast, whipping around something invisible in tight, precise orbits, the same way planets orbit a star. Something with enormous gravity had to be sitting right at that point, holding those stars in place, but nothing was visible there at all. No light, no glow, nothing detectable directly. The only explanation that fit the data was a supermassive black hole. This discovery was so significant that in 2020, it earned the Nobel Prize in Physics. Half of the award went to Roger Penrose for proving mathematically that black holes are an inevitable consequence of general relativity. The other half was shared by Reinhard Genzel and Andrea Ghez, who led competing teams that spent decades independently tracking those orbiting stars, gathering the observational proof that something with the mass of millions of suns had to exist at our galaxy's center. It took nearly 30 years of continuous observation to build a case solid enough to convince the scientific world. This wasn't a lucky guess. It was patient, rigorous science.
So how massive is Sagittarius A star exactly? Based on decades of orbital data, scientists calculated its mass at approximately 4.3 million times the mass of our Sun. That number sounds staggering, and it is. But here's some perspective. Remember TON 618, the black hole containing 66 billion solar masses? Sagittarius A star is over 15,000 times smaller than that. In the world of supermassive black holes, our galaxy's own centerpiece is actually considered relatively modest. It's not the biggest, the brightest, or the most extreme example we know of, but it happens to be ours, close enough to study in extraordinary detail that no other black hole allows for. Among the stars orbiting Sagittarius A star, one in particular has become the star of the show, quite literally. It's called S2, and it completes a full orbit around the black hole in just over 16 years. Compare that to Earth's own 365-day orbit around the Sun. At its closest approach, S2 passes within about 120 astronomical units of the black hole, a distance that would be catastrophic for any planet. But for this star, it's simply another pass in its highly elongated orbital path. Watching S2 loop around an invisible point in space again and again gave astronomers their clearest proof yet that something impossibly massive and completely dark was waiting there. At its closest approach, S2 reaches velocities of nearly 7,700 kilometers per second, about 2.6% of the speed of light. To put that into perspective, that's fast enough to cross the entire distance from Earth to the Moon in less than a minute. No planet, no spacecraft, nothing humanity has ever built comes remotely close to that speed. And S2 does this not once, but every single orbit, swinging past the black hole and slingshotting back out into its long, elongated path, over and over for as long as astronomers have been watching. It's a stark reminder of exactly how extreme the gravity is at the center of our galaxy.
On May 12, 2022, the Event Horizon Telescope collaboration unveiled the first ever image of Sagittarius A, a bright, slightly lumpy ring of light wrapped around a dark center. The image was reconstructed by combining thousands of individual images extracted from observations, revealing a glowing gaseous ring surrounding a black shadow, direct visual evidence of the black hole itself. This wasn't a quick snapshot. The data behind the image had actually been recorded back in April 2017, and it took 5 years of processing to turn that raw information into the picture the world finally saw. For the first time, humanity had an actual photograph of the thing anchoring our entire galaxy together. Getting that image required linking 8 radio observatories from around the planet into a single virtual telescope the size of Earth itself. Individual telescopes in Chile, Hawaii, Antarctica, Spain, Mexico, and Arizona all pointed at the exact same tiny patch of sky at precisely the same moment, each recording their own slice of data. None of them alone had the resolving power to see something so small and so far away, but combined, synchronized down to the nanosecond using atomic clocks, they effectively created a telescope with a dish as wide as our entire planet, the only way to resolve detail fine enough to photograph a black hole 27,000 light-years away. Compared to objects like TON 618 or the blazing quasars we've covered before, Sagittarius A star is surprisingly quiet. It's not surrounded by a brilliant, glowing accretion disk. It's not devouring massive amounts of gas and dust on a regular basis. In fact, astronomers describe it as dramatically underfed, consuming only a tiny fraction of the material available in its surroundings. Some estimates suggest it's currently operating at less than 1/billionth of its theoretical maximum brightness. Nobody fully understands why. It's not that there's nothing nearby to consume. There's plenty of gas drifting close by. For reasons still debated, most of it simply never falls in.
But quiet doesn't mean permanently inactive. If a large cloud of gas, or even a star, drifted too close and got pulled in, Sagittarius A star could wake up dramatically. Astronomers have actually observed something like this before, on a smaller scale, brief flares where its brightness suddenly spikes by a factor of 40 or more, lasting anywhere from minutes to hours before settling back down. If something significantly larger fell in, the black hole could begin actively feeding, developing a genuine glowing accretion disk, and Sagittarius A would transform from the quiet, invisible object we know today into something resembling the blazing quasars we've explored in other videos. If you track individual stars in the ultra-dense cluster at the very center of the Milky Way, you will see them swinging in sharp orbits around Sagittarius A's vast, invisible mass. These are perilous orbits, and sometimes a star wanders just a little too close to that lurking monster. When that happens, the black hole's gravity can tidally destroy the star, with some of the shredded material falling in and creating a hot, brief flare of light, an event astronomers call a tidal disruption. Astronomers estimate these events happen only once every 10,000 to 100,000 years around any given supermassive black hole, making it exceptionally rare, but not impossible, even here at home.
Right now, our Sun is orbiting the galactic center at roughly 240 kilometers per second, from a distance of about 8,000 parsecs, over 26,000 light-years away. That means, yes, technically, we are moving toward Sagittarius A, but not in any way that should concern you. This is a stable, roughly circular orbit, the same kind that's kept our solar system at a safe distance for the last 4.6 billion years. At this rate, completing just one full orbit around the galactic center takes the Sun approximately 225 to 250 million years. The last time we were in this exact position, dinosaurs hadn't even appeared on Earth yet.
Despite decades of study and an actual photograph, huge questions about Sagittarius A star remain unanswered. Why is it so unusually quiet compared to other supermassive black holes of similar mass? How exactly did it grow to 4.3 million solar masses in the first place? And how long did that process take? Scientists are also still debating its spin, how fast it rotates, and in which direction relative to the galaxy around it. Details that affect everything from how it might behave in the future to how accurately our models of gravity hold up in its presence. The EHT team is already working on the next step, hoping to capture video instead of a single still image.
There's something strange about all of this. We've sent spacecraft past every planet in our solar system. We've landed rovers on Mars, brought back samples from asteroids, photographed the surface of Pluto up close. But the true center of our own galaxy, the point every single star, every planet, every one of us has been quietly orbiting our entire existence, remained completely invisible until just a few years ago. For nearly all of human history, we lived our lives circling something we couldn't see, couldn't prove, and could only infer from the way everything else moved around it. Now, for the first time, we finally have a picture of home's true center.
So the next time you look up at the night sky, remember this: everything you can see, every star, every constellation, is bound together by something we spent nearly a century proving exists, and only a few years actually seeing. Sagittarius A doesn't blaze, doesn't announce itself, doesn't demand attention the way TON 618 or a dying star like Betelgeuse does. It just quietly holds an entire galaxy together, 26,000 light-years away, patiently waiting at the center of everything we call home. Sometimes, the most important things in the universe are the ones that stay completely silent. Subscribe. There are still more mysteries hiding in plain sight, waiting to be explored.